Namaste. Welcome to the Indian Knowledge Systems Primer Course for Children offered by Anaadi Foundation. In today's Bharatiya Ganita lecture, we will look at computing cubes. As we saw earlier, there are 8 arithmetic operations in the Indian mathematical tradition. Of these, we have seen Varga and Vargamoola in our previous sessions. Today, let us look at the 7th of these operations called Ghana or cubing. The clear meaning of a cube has been given by Aryabhata in his Aryabhatiya in 499 CE in the following verse.
सदृशत्रय संवर्गः घनस्तथा द्वादशाश्र स्यात्.
In this verse, Aryabhata tells us that the product of 3 equal quantities, Sadrisha meaning equal, Traya meaning 3 and Samvargaha meaning the product. So, the product of 3 equal quantities as well as a solid having 12 equal edges is called a cube. The second part of the verse includes Dwadasha meaning 12 and Ashrihi meaning edges, therefore saying that a cube is also a solid which has 12 equal edges. The Sanskrit term for cube is Ghana or Ghanaphala. In modern mathematics, it is denoted by writing 3 in the right top of the number which is cubed. Such a notation is called the power or exponent of a number. Let us see here. So, a multiplied by a equals a cube. Before learning to compute a cube, it is helpful to learn an algebraic identity that is employed in finding the cube as well as the cube root. Cubic identity. So, this algebraic identity that is employed in finding the cube as well as the cube root is listed out here. A plus b whole cube equals a cube plus 3a square b plus 3ab square plus b cube. Let us first learn the geometric demonstration or the upapatti for this identity as given by Neelakantha Somayaji in the 15th century in his commentary Aryabhatiya Bhashya. In Indian mathematics, upapattis hold a very special place. Upapattis are reasonings. They entail one or more of the following. First, utapattis can be logical sequence of arguments. Second, an upapatti can be a geometric demonstration. And third, it can also be in the form of mathematical analysis. Upapattis give us the reasoning behind why we do something. For the purpose of this demonstration, Neelakantha asks us to take a cube made up of clay. Now, once you have the cube with you, follow the legend of north, south and east, west as directed here on the screen. Next, Neelakantha asks us to slice this cube in 3 ways: along the north and the south, east, west and a cross-sectional slice. But where and how should we make these particular slices? Let us say we take a cube with x dimension. This x number can be split into 2 parts called A and B. For instance, if you take a cube with dimension 7 centimeter, where all of its sides are 7 centimeters, then we can split it into 2 parts where A can be 2 and B can be 5. Now, let us make the first cut across the east-west line such that we get A here and B over here. Next, make a cut along the north-south direction such that a length of A is left here and B is left here. Finally, we make a cross-sectional cut such that we take A from the bottom and B is remaining at the top. Finally, make a cross-sectional cut this way such that a length of A is remaining at the bottom and B is at the top. Thus, we have made 3 total cuts so far. The first along the east-west direction, the second along the north-south direction, and the third cross-sectional cut this way. These 3 cuts have resulted in 8 different blocks, as we can see, 4 at the top and 4 at the bottom. What are these 8 blocks like? Let us see. As we can see, we now have 8 different blocks. What are these blocks? The block from the back is a cube. The block marked in blue in the front on top is also a cube. The other remaining 6 blocks are all cuboids. Now, in order to truly understand and appreciate this Upapatti which we have taken in this lecture, it is best to do this experiment by yourself. Take fresh clay, take Play-Doh, take any medium that you can make this cube out of and try the slicing experiment yourself to see how intuitive and how logically we can find out the method of finding a cube. So, of the 8 blocks which are now available to us after slicing, we realize that the block at the back is of the dimension A cross A cross A. This is an A cube which we got after slicing. And these 3 cuboids which share a complete surface with this A cube are of the dimension A into B equaling A square B. These respective cuboids are in the northwest top, in the northeast bottom and the southwest bottom. Next, we observe that the cube on the top is of dimension B into B into B. So, this is a B cube which we have gotten after our slicing process, and the 3 cuboids which share a surface with this B cube are of the dimension B into B into A, giving them the volume of AB square. Putting these components together, we find that A plus B whole cube equals A cube plus 3A square B plus 3AB square plus B cube. Neelakantha's ingenious demonstration or Upapatti helps us arrive at this particular cubic identity which has been used time and again to find both cubes as well as cube roots. Now, moving on to computing the cube. Bhaskaracharya in his Leelavati gives us 3 methods to compute cubes. We shall see the first one here through this particular verse.
समत्रिघातश्च घनः प्रदिष्टः स्थाप्यो घनोऽन्त्यस्य ततोऽन्त्यवर्गः आदित्रिनिघ्नस्तत आदिवर्गः त्र्यन्त्याहतोऽथाधिघनश्च सर्वे स्थानान्तरत्वेन युता घनः स्यात्.
In this particular verse, Bhaskaracharya tells us that the product of 3 equal quantities is called a cube. As you may remember from our earlier lectures, the leftmost digit that one encounters is called the antya. So, to start computing the cube, he says that find the cube of the antya which is equivalent to the A cube that we just saw in our algebraic identity. Thereafter, take the square of the antya multiplied by Adi and 3 which equals 3A square B. Thereafter, the square of the Adi multiplied by 3 and the antya which equals 3AB square in our algebraic identity, and finally take the cube of the Adi which should be B cube. All these must be placed according to their place values and added. This means that we will have to perform an sliding function. Let us see how. Let us try computing 12 cube. In this case, 1 will be our Antya and 2 will be our Adi. To start the process, we'll write down our Antya and cube it. So 1 cube gives us 1. Next, we find 3a square b, which is 3 into our Antya squared multiplied by 2, which is our Adi. This gives us 6, and this is precisely where we will also slide it by one place, as you can see on the screen. Next, we will try finding 3ab square, which is 3 into 1, which is our Antya, multiplied by 2 square, which is our Adi. So 3 into 1 into 2 square gives us 12, placed this way. Finally, we find b cube, which is 2 cube, meaning 8. We slide one place and place it. Now, to get our final answer, we must add each of these in their specific place. So, 8 gives us 8, 2 gives us 2, 6 plus 1 gives us 7 and 1 gives us 1. And that's it. Using this method, we have now gotten our answer. 12 cube is 1728, as you can see. Now, let us try another example. Let us try computing 34 cube. So, as we know, 3 will be our Antya digit and 4 will be our Adi in this particular case. 3 cube gives us 27. Now, for a square b, which is 3 into 3 square into 4, remember that your units digit must be one place towards the right. So, we slide it in this way, right. So, 3 into 3 square into 4 gives us 108. Write 8 here, 0 here and 1 here in this way. Next, we try finding 3ab square, which is 3 into 3 into 4 squared, which is 144. Again, notice how we have slided our numbers one more place to the right and written 144 in this particular way. With each step, we are moving our units digit towards the right. In our final step, we compute b cube, which is 4 cube in our case, right, and we get 64. Again, slid one more side to the right and written in this particular fashion. Now, to get our final answer, we must add all these numbers. So, 4 gives us 4, 6 plus 4 gives us 10, 8 plus 4 plus 1 gives us 13, 7 plus 1 plus 1 gives us 9 and 2 plus 1 gives us 3. So, finally, 34 cube is 39,304. Let's try one more example and see how to apply this technique. We start with 6 cube, which is 216. Next, we try finding 3a square b, which is 3 into 6 square into 5, since 5 is our Adi digit in this particular case, and we get 540. 540, remember to slide your digit one side towards the right and write it in this particular way. Next, we try to compute 3 into ab square, which is 3 into 6 into 5 squared, which gives us 450. Again, we have moved our units digit by one more place and you find 450 written in this fashion. Finally, we compute b cube, which is 5 cube, 125. Now, to get our final answer, we add up all these numbers. So, 5 gives us 5, 2 over here, 6 here, 472 here, and that gives us our final answer. So, 65 cube is 274625, as you can see. I am certain that this is the fastest way of computing a cube instead of doing 65 multiplied by 65 multiplied by 65 and so on. Let's try computing 125 cube. Now, what do we do when we have 3-digit numbers or 4-digit numbers and so on, right? We first calculate the cube of 12 independently. Once we have calculated 12 cube, subsequently we will take 12 as our Antya and 5 as our Adi digit. Now, to find 125 cube, we start with the cube of our Antya, which is 12 cube, written here as 1728. Next, we calculate 3a square b as 2160. Remember again to slide along each step of your calculation. After that, we compute 3 into 12 into 5 square, which is 3ab square, 900. Finally, we take our b cube, which is 5 cube in this case, and write it as 125. To get our final answer, we start adding from this particular block, because this is where we placed our a cube. Now starting to add, we will get 5 gives us 5, 2 gives us 2, 1 gives us 1, 9 plus 6 plus 8 gives us 23 here, 2 plus 2 plus 1 gives us 5, 7 plus 2 gives us 9, and 1 gives us 1. So 125 cube is 1953125. Try computing the cubes of different numbers that you may like, you may want to compute, and see if you can beat the calculator. I bet with more practice, when we apply this technique, we become faster and we are able to get answers very, very quickly. I hope you enjoyed this session on cubes, and I hope you will follow further. Thank you.